Hi guys, Miss Scott here. Thanks for tuning into this video on the Geometry 5.3 notes. We're going to start by giving you your bad joke of the day. So what did the dying router say to his new replacement? Tell my Wi-Fi love her. All right, so let's jump into the lesson. So this is about angle bisectors, and we're going to see what happens when a point is on the angle bisector of a triangle. So if you need to pause the video, go ahead and do that, but what you need to do is jot down this essential question, and then there's 3 vocab words here that you can write down. So go ahead and pause the video, jot those down, and we'll talk about them in a little bit. All right, so this first definition, an angle bisector is just if you have an angle, it's a ray that cuts this into 2 congruent angles right here. So the angle bisector would be this ray right here. Okay, an inscribed circle is a circle that intersects each side of a triangle one time. So say we have this triangle right here. What an inscribed circle would do is just touch each of those vertices of the triangle. So there'd be a point here on the circle, here, and here. And lastly, the incenter, we're actually not going to draw a picture of that because we are going to do that in the example down below. But if you draw the 3 angle bisectors in a triangle, it's the point where those 3 angle bisectors intersect. We call that the incenter. Alright, so I'm actually going to link you to another video to go through this example here. It turns out that I need to use a compass, which is just not working correctly on the iPad. So I have to use my laptop, but I will send you the link to that video. So somewhere in this area there will be a link. Click that, watch the video that goes with this example, and then we will get back to it. But after watching that video, you should have realized these 3 things. So it's in these 3 theorems here. The first one is if a point is on the angle bisector of an angle, all right, then it is equidistant from the 2 sides of the triangle. And we're going to use that and this next theorem in a couple of examples. And it works both ways, so we have the converse of that theorem, which tells us if a point is equidistant from the 2 sides of an angle, then it is on the angle bisector of that angle. All right, and then the third theorem tells us that the angle bisectors intersect at a point. We mentioned that earlier. That point is called the incenter, and it is equidistant to all the sides of the triangle. So it's kind of a combination of theorem 5.5 and 5.6. All right, so let's use that on a couple of examples here. First of all, you can see that this point is on the angle bisector. So that means, so we actually need to know this angle is the same as this angle that was not given to us, but it should be, so go ahead and put those 2 arcs there. And if that's true, this point then is on the angle bisector, which means it's equidistant to the 2 sides of the angle, which tells us that we can say 10x plus 10 equals 8x plus 20. Okay, so we're going to use that to find the value of x and then tell what theorem was used. So if we go ahead and solve this, which we can start by getting our x's on one side. So we get 2x plus 10 equals 20. Go ahead and subtract 10 from both sides. We get 2x equals 10. And if we cut that in half, we see x is 5. All right, and we also have to say what theorem was used. So here we know that this point is on the angle bisector, so it was the same distance from each side of the angle. So that's actually this theorem 5.5. If a point is on the angle bisector, then it is equidistant. So we can set the two lengths equal to each other. So we also have to say that theorem 5.5 was the theorem that we used. Okay, let's look at one more example here using those theorems. Now this tells us that this distance and this distance are the same length. So that means this must be, this ray right here must be the angle bisector. Meaning this angle 6x has to equal this angle 2x plus 16. So let's go ahead and say that. And we can start by subtracting 2x from both sides. We end up with 4x equals 16, and if we divide by 4, you can see x equals 4. Now this one, we started with the fact that these two segments were the same length, so they are the same distance from the sides of the angle, so that this was the angle bisector. So if we look at our theorems, that is theorem 5.6, if a point is equidistant from the two sides of an angle, then it is on the angle bisector. So we knew that that had to be the angle bisector. All right, so the theorem we used was theorem 5.6. All right, so let's move along to another example here. They tell us that the incenter of triangle PQR is point T. So this point right in the middle is the incenter. And we're going to use that to find the length of the following. So if you remember that incenter is the same distance from that point to each side of the triangle. So from T to W, T to S, and T to U all have to be the same length. And we can see that TW is 15, so that means TS is 15, TU is 15, and we can just fill those in for number 4 and 5 here. All right, now this third example is a little bit more work than that. We're going to find this length here, length UR, and we've got actually this little right triangle right here that we're going to have to use. I'm going to call this length UR, let's call that X, because we don't know it. We are actually going to have to use the Pythagorean theorem here. So we will say x squared plus 15 squared equals the hypotenuse, which is 26. So if we go ahead and solve that, we end up with x squared plus 225 equals 26 squared. Let me grab a calculator. I don't remember that one off the top of my head. So 26 squared is 676. So we can go ahead and subtract 225 from both sides. We end up with x squared equals, let's see, that'd be 451. So then to get x by itself, we square root both sides, and we will not get a nice number when we do that. If you take the square root of 451, it looks like we end up with about 21.2. All right, so that one was a little more work, but using that Pythagorean theorem, we could figure it out. Okay, and again, I do need to use a compass on example 7 here. So if you could click on, I will put a link somewhere here that you can click on again to get the last example. All right, well, thank you guys for watching. Don't forget to go back and watch those 2 videos on constructing the incenter. Feel free to comment down below if you have any questions or concerns, and we will see you guys next time. Thanks for watching.